So welcome to linear integrated circuit class. Today we are going to see the non-inverting operational amplifier, open loop and closed loop. So here in this diagram you can see the open loop non-inverting amplifier and closed loop non-inverting amplifier. So non-inverting means the input voltage given to the non-inverting pin. So if the input is given in the inverting pin, then it is called inverting operational amplifier. So this is the closed loop setup of a non-inverting amplifier. So we derive the closed loop gain of the this amplifier, and we will see what are the advantage of non-inverting amplifier over inverting amplifier. So generally the gain of open loop gain of this non-inverting amplifier is, so AV is equal to V out by V in. So V out is equal to output is equal to AV into V in. So V in is nothing but V plus minus V minus. So here V minus is grounded, so that is 0. So we will get AV into that open loop gain into V, that is V in. So this is the gain of open loop non-inverting amplifier. And let's see the closed loop non-inverting operational amplifier. So this is a non-inverting operational amplifier closed loop, and this is R1 resistor, this is resistor RF feedback resistor, this is input voltage Vi. So assume there is a virtual short, so input voltage comes into the non-inverting pin Vi, so the same voltage occurs in this point. It is also V in, keep it as V in. So now find out V in. So V in is equal to, applying the voltage divider rule, V in is equal to R1 divided by R1 plus RF into V naught, isn't it? So bring back this V out here, you will get V in by V naught is equal to R1 divided by R1 plus RF. So we know the voltage gain is equal to V out by V in. So the closed loop voltage gain is equal to V out by V in is equal to you reverse get, you will get R1 plus RF divided by R1. So simplify, you will get 1 plus RF by R1. This is closed loop voltage gain of non-inverting amplifier. So we can vary the closed loop gain by using the value of RF, by varying the value of RF and R1. So comparing to the inverting operational amplifier, the gain will be more in the non-inverting amplifier. So there the gain is, the closed loop gain is minus RF by R1. Here it is 1 plus RF by R1. So you will get the more gain compared to inverting operational amplifier. So let's see what are the advantage of this inverting operational amplifier. So here let's calculate the input impedance of both inverting and non-inverting amplifier. So this is the inverting amplifier. So here the input impedance is nothing but the impedance what we have seen in the input voltage side. This is input impedance, and this is the current flowing. This is I in. Generally impedance can be calculated V in divided by I in. So here calculate I in is nothing but V in divided by the resistance R in. So if you substitute this I in to is impedance equation, you will get Z in is equal to R in. So if this resistance value is very low, then input impedance will be low in case of the inverting amplifier. And let's see for non-inverting amplifier the input impedance. So here this is a non-inverting Opamp. So here this is the input voltage. So and you will get the current here, input current I in. So the input impedance is equal to V in divided by I in. So if you consider this Opamp is an ideal Opamp, so in the ideal Opamp there won't be any current through this terminal, so I in is equal to 0. So if you substitute here V in divided by 0, then Z in impedance is infinity. So if any circuit having input impedance is infinity, so you can use that circuit. You can use that circuit as the output side of any circuit, and it will not be loaded. So if you see the input voltage, so if this is the input voltage, consider the circuit Vs and resistance of Rs. This is connected to a circuit. It has the impedance of Zs. So if we consider both resistance of and the impedance of the circuit is same, then if we are calculating the output of this circuit, V out is equal to Zs divided by Zs plus Rs into Vs. So if Rs and Zs both are same, you will get Vs by 2. So V out is equal to Vs by 2. So the output will be the half of the input voltage. So if you consider this Zs, if the impedance is infinity, so in the output side, whatever the voltage we are applied in the input side, you will get the same in the output side. So there won't be any voltage drop at the output side. So we can use this non-inverting Opamp as voltage follower. So you see here So in the non-inverting closed loop op-amp configuration, we have seen that input impedance, that is on R f is equal to 0 and input resistance Ri is equal to infinity, then it will act as a voltage follower. This is V in plus and minus, this is V out. So this setup will be act as a voltage follower, or we can say this will act as a voltage buffer. We can use this configuration in order to separate a two circuit. So consider this is circuit 1. So you connect to voltage follower because it has the high input impedance, and circuit 2. So this this circuit will not be loaded by this output voltage of circuit because it has high input impedance, and it has the same voltage whatever occurs in the input side, it will be given to the output side. So in the next class we will see the AC and DC characteristics of operational amplifier. Thank you.